In this video, we will discuss about Find Champion 2. There are n teams numbered from 0 to n-1 in a tournament. Each team is also a node in a DAG. You are given the integer n and a 0 index 2D integer array edges of length m representing the DAG, where edges of I indicates that there is a directed edge from team U to team V in the graph. A directed edge from A to B in the graph means that the team A is stronger than the team B and team B is weaker than team A. Team A will be the champion of the tournament if there is no team B that is stronger than team A. Return the team that will be the champion of the tournament if there is a unique champion, otherwise return -1. So what they are saying is that in the input we are given an integer n and we are given a 2D vector edges, which denotes that there is a directed edge from 0 to 1. Right? So basically if we try to draw this graph, then this is the node 0. It has a directed edge towards 1. Right? So we will have a node 1. Then this node 1 has a directed edge towards node 2. So this is what our graph will look like. Now in this particular graph, what they are saying is that a particular team, if it has a directed edge starting from it and going towards team B. So if this is team A and it has a directed edge going towards team B, then this team A is stronger than team B and team B will be weaker than team A. Now what we need to do is we need to find out the champion. So now who is a champion? So a team for which there is no other team in the graph which is stronger than that particular team. That is our champion. Now if in this case there are multiple champions, then we need to return -1. Otherwise we need to return the node which is the champion. Right? So if you see here in this graph, from node 0, there is an edge starting and going towards node 1. Meaning node 1 is weaker than node 0. So this particular node cannot be our answer, right? Because it is weaker. Then if you see for node 2, there is a directed edge that is starting from 1 and going towards 2, which means 2 is weaker than 1. Then that means this also cannot be our answer. But if you see for node 0, it is not weaker than any of the nodes in the graph, right? So then that means this can be our answer. And since there is only one such node, so we can return 0 as our answer, right? Now if we go towards the next test case, so here the number of nodes that are given to us is 4. So there is a directed edge starting from node 0 and going towards node 2. Then we have a directed edge starting from 1 going towards 3. So from 1 towards 3, right? Then in this from 1 towards 2. So from 1 towards 2, right? Now if we see for this node 0, it is having only one directed edge starting from itself and going towards the node 2. Then that means node 2 is weaker than this 0 and also it is weaker than 1. So node 2 cannot be our answer, but node 0 can be, because node 0 is not weaker than any of the nodes. Then if we consider node 1 and 3, so in this again there is a directed edge starting from node 1 and going towards node 3, right? Which means node 3 is weaker than 1. So node 3 also cannot be our answer. And if we see for node 1, it is having only two directed edges which are always starting from it. Then that means it is stronger than both of these. So 1 is also not weaker than any of the nodes in the graph. So this can also be our answer, right? Now in this particular case, we are having two such nodes. And whenever there are multiple such nodes, then our answer has to be -1. In this case, it was 0, right? So how are you going to solve this? So if you closely look at these two graphs, why this node 0 is our answer? Because there was no edge which was coming towards it, right? If there had been an edge that started from some node and came at this particular node, then node 0 would be weaker than that particular node, and then we could not mark it as our answer, right? But in this case, there is no edge which is coming towards node 0, right? In this case also, if you see, for node 0, there is no edge that is coming towards it. The edges are only starting from node 0. For node 1 also, there is no edge which is coming towards it. The only edges that are there, all of them are starting from 1, right? So we need to find the count of such nodes, right? Now see, this concept in graph is known as in degree. So in a graph, we basically have an in degree and an out degree. So in degree basically denotes the number of edges that are coming towards a particular node, right? And out degree denotes the number of edges that are moving out of that node, right? So in this particular case, for this 0, there are no edges that are coming towards it, right? So then that means in this particular case, the in degree of node 0 is 0, right? That is why it is our answer. And in this particular case, again for node 0, there is no node that is coming towards it, right? So the in degree of this node 0 is also 0. And for this one also, there is no edge that is coming towards it. So its in degree is also 0. So through the in degree, we are able to identify such nodes, right? So now through the input, how are you going to identify the in degree? So see, we are given a 2D vector, right? What is it denoting? That there is a directed edge which is starting from 0 and coming towards 2. When it is coming towards 2, then that means the in degree of 2 is 1 at this particular point, right? So what you can do is that you can maintain some map or vector to count the in degree of all the nodes in the graph, right? So the nodes are given to you as 4 and all of them are labeled to 0 to n minus 1. So we can maintain a vector of size n, right? Where 0th index will denote the in degree of 0th node, first index will denote the in degree of first node, and so on, right? So we will take a vector. So it will be of size 4 in this case, and the indexes will be 0, 1, 2, 3, right? Initially, we can keep the in degree of all the nodes as 0. Now here you will see there is a directed edge starting from 0 going towards 2. Then that means there is an edge coming towards 2. So the in degree of 2 will become 1, right? Then if we see next, so there is a directed edge starting from 1 and going towards 3. So the in degree of 3 will be incremented by 1, so it will also become 1. Then again there is a directed edge starting from 1 and going towards 2, so 2 has one more incoming edge, so its in degree will be incremented by 1, so it will become 2. Now we are done with all the edges. So now in your vector you will see that how many nodes are there for which the in degree is 0. So in this case it is 2. So whenever it is more than 1, you can return -1. Otherwise, since there will be only 1 0 here, you can return that particular index from the vector, right? So how are we updating this? So basically when we will be looping in our edges, and let's suppose this is denoted by a variable edge, then what you will do in your vector at the index edge 1, you will do plus plus. Basically you are incrementing the in degree by 1, right? So let's quickly code it out. So first of all, let's create a vector. So this vector will be of size n and initially all the values will be 0. This is for counting the in degrees. Then we will loop in our edges. So for auto edge in edges. Now inside this, we need to update the in degree, right? So we will do v of edge of 1 plus plus, right? So this will give us the in degrees of all the nodes in our graph. Now we need to find out who is going to be the champion, and also we need to find the count also, right? So we'll take two variables. Let's suppose champ. So initially we do not have a champion, so let it be -1, and count we will take as 0. Then we will loop inside our vector, right? So int I equals to 0, I less than n, I plus plus, and then inside this we will check that if v of I is 0, meaning the in degree of node I is 0, then that means it can be a champion. So we will do count plus plus, right? And we will update the champion to I, right? Now at the end, after this loop, you can check that if the count is greater than 1, in that case answer will be -1, right? Otherwise what will be our answer? So we are updating the node in this variable champ, so we can return our answer as champ, right? Now here inside this itself, you can check that if at any point the count is becoming 2, then you can stop there itself. So that is also one of the possibilities, right? So here we are looping in the edges vector that is given to us, right? And the total number of edges that are given to us in the question was m, right? So this particular loop is running m times, and here we are looping n times, right, which is equal to the number of nodes. So this is running n times. So what will be the overall time complexity of our code? It will be order of n plus m, right? And what will be the space complexity? So we have only taken a vector which is equal to the number of nodes, that is n, right? So the space complexity will be order of n, right? So let's quickly run this. Our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.